Hello, hello, hello. Good morning. What is it? It is Tuesday, the 11th of November. Welcome back to my Tutor Live Solve series. Today, I'm going to be doing NSAA, continuing to go through and do live solves of all the NSAA papers. So you see that, see how to go through them, see if there are any challenges putting together the full run. And as usual here, there's places to go to find how to do the correct answers under perfect conditions. Doing the exam is not going to be under perfect conditions. There's going to be things that happen. There's going to be reasons why you can't perform at your absolute best. And so it's what do you do when you're in the room actually like dealing with the stress and the pressure, going through trying to put together the best solve you can. So that's what I'm going to do today. Definitely feeling tired, definitely not feeling at my best, but it's entirely possible that you're going to have like that happen on the real day. If, for instance, the only slot available to you at a test center is one that's earlier than you would like. So it may not be perfect today, but again, it's more about understanding the challenges that faces. So, for instance, if I can tell that my brain's not working right, how do I pivot and adjust? And that exam technique of sensing what I have in me on the day and trying to massage out every single mark possible to get as good a mark possible as I, possibly can. Um, I'm also only going to be doing NSAA because pre-2020, the format's a little bit differently, where now the NSAA does have the Math 2 in it. Not exactly the same number of questions as the ENGAA, but basically equivalent. I've had a rough look, and the questions are like the same, but the numbers are slightly off. So it now becomes much more reasonable to do it all within the NSAA. So that's what I'm going to do because I come more from the sciences side than the engineering side. But the NSAA is like in terms of the questions, it is exactly the same. So if you're looking at an ENGAA paper, you'll recognize a lot of these questions. And like I say, this is more about the act of putting together a full run rather than me sort of going through sort of question by question, which you can find elsewhere. I'm going to keeping split times. So for anyone new here, the way I advise doing this, because the ESAT is so time pressured at 90 seconds a question, you can't be wasting your time on questions that aren't good for you. So I advocate for what I call a multiple pass system, where the first pass, you only do the questions that are good for you, that give you confidence, that you know you can do and you can do quickly. And then in the second pass, you go up and mop up anything else. And this way, you spend your time answering questions. So, for instance, the first question you do is really going to set the tone and ground you in the paper and make you think, oh, yeah, this is going well. So, if you start off and you get like a bad question, rather than waste 5 minutes on it and think this paper's going terribly, just skip it, find a good question. So, typically, what I've been doing is going from the back because I know that the past papers they have online are set up such that they start easy and then get harder as you move towards the end. But I've been doing a lot of that, and that's not how I would do the real thing. And that certainly trains me up for the worst case scenario, which is getting hit with the hardest question first. And maybe I will do that in the Math 2, actually. But I also want to mix it up a little bit. And for the physics and the Math 1, I'm going to go from the front. This time, it means that the first questions I see are going to be really easy in comparison to the ones at the end. And that will train me up for a different worst case scenario. So that'll train me up for the worst case scenario that things start easy, lull me into a false sense of security. I start taking more time than I can afford on the easy questions, and then don't have enough time for the harder questions right at the end. So I'm going to keep taking my split. In fact, let me just switch to the Wi-Fi on my phone. I am going to keep taking split times, and if I spot anything noticeable, I'll stick it on the screen when I'm doing my marking. But I don't think it's hugely meaningful. It's more, I'll put something if it's sort of, stand out. So I've got, let me start my screen share and get you guys, make sure you can actually see it. So we're going to do the entire screen. Just so you can actually, What's happening here? That's right, take that. And all of my adjustments have gone out the window. So hold on, just reformatting it. Okay. Trying to give you as much space as possible. And by you, I obviously mean me. Cool, everything working. It looks okay. So we're going to start with math 1, and we'll see how the run goes. I am going to take split times. I've got my pen and paper in case I need to write down questions to come back to. Yeah, I don't think I need to say anything else. Let's just get into it. So, math 1 will begin now. All right, so square the first, square the last, twice the middle, 2. So 7 plus 3 plus 2 root 21 minus 7 plus 3 minus 2 root 21. Cancels, 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 cancels. 4 root 21. F, done. Okay, question 2. Okay, this is going to be fine. We just expand out the brackets. Minus 1, minus 2/3 x. We don't make an execution error. That turns into a plus, less than x. Let's move the x's to one side, everything else to the other. So in fact, let me 9 over 6x minus 4 over 6x minus 6 over 6x less than 1 minus 8 over 3. Not making any. Okay, so 5 minutes, it's minus a 6x. Oops. Should have moved it over to the other side. That is minus 5 over 3. Let's add things across so as not to annoy the sign. So that means 10 less than x, which is h. Let me just check. Yeah, that's fine. I'll move on. I'll come back and check that if I have time, but I don't think I will. And again, I should really make sure I'm getting good time on this run. In fact, I need to step on the gas a little bit. So, lock in. Oh, rearrange. This is fine. So y minus 3. No, in fact, 4 stuffed squared equals 3 minus y. So that over 4 plus minus square rooted. And then 1 plus minus root 3 minus y over 4. Because that's 1 minus x over 2 in there. So we're going to swap them round. It's going to be x over 2. So if I double that up, so 2 plus or minus 3 minus y over 4 is e. Lock that in. Next. Okay, question 4. Resistance is directly proportional to the square of the speed of the car. The speed goes to 1.2 v. So resistance is 1.44 v. So the resistance has increased by 44% to become, 1.44. Good. Okay. Passes through those points, so let's plug it in. So 6 equals 4p plus 2q, q. And minus 4 equals 16p plus 4q. So I'll double this one up and say that 12 is equal to 8p plus 4q. Subtract that. That minus that is minus 16. That minus that is 8p. So p equals minus 2. And 6 is equal to minus 8 plus 2q. So 14 equals 2q and q equals 7. So q minus p is equal to 9, which is e. Algebraic fractions I quite enjoy. So that's 4 minus x, 3x plus 1 all over x squared into 3x x. Let's get this factorized. So it's minus 1 there, plus 1 there, cancels, 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 cancels. So it becomes 4x minus 1 minus 1 all over x minus 1. Let's expand this out. 4x squared minus 4x minus 1 all over x minus 1 looks like D. Okay. The ball for a garden game is a sphere of that volume. Radius is okay, so this is going to be length, area, volume stuff. The radius is reduced by 25%. So let's say it's 1 to 3/4. That means the volume ratio is 1 to 27 over 64. So if the original is 192, we have to multiply by 192 to get the size of the children's ball. So 27 over 64 times 192 is not something I want to do, but I can see that there are, let's just do it gradually. So 96 and 32. Okay, that's just 3. And 3 times 27 is 81, which is B. Okay, so we have a right angle triangle. Okay, so it's right angled, so Pythagoras applies. So 3x squared equals x plus 4 squared and 2x plus 2 squared. So we have x squared and 8x and 16, 4x squared and 8x and 4. So 5x squared and 16x and 20. So moving that over, we have 2x squared, 16x, and 20, where we can divide everything by 2. So I absolutely will. Oh, I done something wrong? Does that don't factorize? That does not factorize. Square the first, square the last, twice the middle 2. Square the first, square the last, twice the middle 2. 16, 20, 5. Oh, that squared is 9x squared. Oops. Silly me. So moving all of this over then, 4x squared minus 16x minus 20 is 0. So dividing by 4. And I was just so suspicious because that didn't factorize. And that's so not ESAT. So that's good exam technique training, knowing the paper I'm solving. So x is 5 or x is minus 1. X can't be negative because length can't be negative. X is 5. So the side lengths are 9 and 12. So base times side over 2 cancels for 6 is 54, which is, you can't see that. Oops. You know the area of a triangle. So that is F. I'll have lost time on that. And I only have 20. So I suppose I'm doing okay on time, though, from the earlier questions. Okay, so power laws. Okay, these are all powers of 3. So that's going to be 3 to the, I can afford to zoom in a little bit here. 3 to this, so you can see the powers, in fact, a little bit more. So here, 3, and that's going to be squared up to, so the 4x minus 2, and that's going to be times 3 to the minus 3x equals, and that's 3 to the 4, so 3 to the 4x. When I say that, I mean 81, minus because it's 1 over. So that is going to be 3 to the x minus 2 equals 3 to the 4x. And then comparing the powers, we see that 4x is equal to x minus 2, which means that 3x equals minus 2, and x is minus 2/3, which is A. Okay. Okay, we got ourselves a rhombus. Diagonals of a let me draw my rhombus. I know that the diagonals of a rhombus are perpendicular bisectors. And the area of PQRS is that. Oh, crap. Do I know? The area of a rhombus when it comes to its diagonals. I don't need to. I don't need to because I can see this divides 2. So if that, it would have been 8 minus 2x. That becomes 4 minus x and 4 minus x. And this whole diagonal here is 3x plus 2. And I can half base times height on that. And double it up. So it becomes half base times height on this triangle would be a half of 4 minus x all over 3x plus 2 for that triangle. Double it up for that. So it just becomes that. And that is the area of the triangle. Rhombus even, which is 11. Cool. Okay, got my way through that situation. Minus 3x squared from that. Minus 2 plus 12 is plus 10x. Plus 8 equals 11. Move it over to keep the x squared positive. So 0 equals 3x squared minus 10x plus 3. So I'm going to get 3x and x. So it's going to be minus 3 minus 1. X is a third, or x is 3. Two possible lengths of PR then. So PR is either equal to that times 3 is 1 plus 2 is 3. That times 3 is 9 plus 2 is 11. The difference between those is 8, which is D. Okay. I shouldn't really have done that actually in a first pass, just to ensure I have time for it. I was feeling okay on time though. So again, this is more what I was talking about the psychology of doing a run this way. So we have these right angles at Q. So PQ 3, 4. So these are 3, 4, 5 triangles. So these are both 5. What is the length of QS? Well, those are both 5. No. Also no. Oh no, even less. Okay, there we go. So something like this. Drop down. Let's go. So that's 60. We're going to get resolving triangles. So this would be a 1, 2, root 3. So if I scale that up by a factor of 1.5, that'll be 1.5. That'll be 1.5. This would have been 5, and 5 is 10, minus 3 is 7. And so QS is 7, which is not an answer. Womp womp. Because it's not 60 degrees. What am I talking about? Absolute madness. Okay, so that's only, okay. Take 2. If that is alpha, that is going to be beta, which is 90 minus alpha. That is going to be alpha. That is going to be beta, which is 90 minus alpha. Beta, alpha, beta, alpha, beta, alpha, alpha, beta. So we see a lot of similarity. Okay, so instead I'm going to... So it was a 3, 4, 5 with beta on the top. And that has been scaled in this triangle to have the 4 be the hypotenuse. So these then become, divide 5 times 4 on these becomes 16 over 5. Divide 5 times 12 over 5. So the alpha side is 12 over 5. This is 16 over 5. Multiply that by 2, we get 32 over 5, which is 6.4, which is the length of QS, which is E. Okay. I'm definitely burning through time now, and I need to not do that. Come on, Patrick, where are your multiple passes? Don't be brand new. Total of 3 numbers is that. So P, okay, let's just combine So it's 5 to 7 and 4 to 11. Let's make these both 28 by multiplying this by 4, by multiplying this by 7. So 48. So 40. So 97 and 28 is 25 and 100 is 125 parts. So we got to triple this up to make it 60. 84. Oh man, my mental math. 231. Value of p plus r therefore is 291. Man, I am not in the mood this morning. I'm sure you guys have been there. Ooh, okay. 13. I'm not a morning person. Right, straight line p has equation something, intercepts the y-axis there. Well, let's find that. Equals 2x plus 12 plus 4. So it's 0p equals 4. Straight line q is parallel to p, has the same gradient, passes through this point. Okay, so the other one, y is equal to 2/3 x plus q. Plug that in, so -1 equals 4 plus q, so q equals -5. P minus q is 9, which is D. Great. 14. Vertices in that specific order. Oh, man. Okay, no, don't get in this mindset. No, everything's fine. So 4, 5, 4, 8, 10, 8, 10, 5. P, Q, R, S. Rotation of 90 degrees about P. So this will now be 3 across. So that was going 3 up and 6 across. It's now going 3 across and 6 down. So 3 across would take that to 7, 5, where that being 4, 5. And 6 down takes us to 7 minus 1 there. QRS, followed by a reflection in the x-axis will take us to 7, 1, and 7 minus 5. So R was there, goes there, it goes there. 7, 1 is G. Box A is 10 balls, 6 blue, 6 red, 4 blue. All the balls are identical in every respect apart from color. One of the 2 boxes is chosen at random by tossing 2 fair coins. 1 ball is then selected at random. So, okay, how do I take a red? I either there's a quarter chance of getting both heads and then selecting from A, where the probability of getting a red is 6/10. Or it's the 3/4 chance of not getting 2 heads. And I select a red, which is 3 out of 15. I would really like for these numbers to be better. So I can make that 1, 5. I can make that 3, 5, and then they're the same. So it's 3 plus 3 is 6/20 is 3/10 is C. I do quite like bearings, actually. So 16, and I'm doing all right on time. Distance from Tunbridge to Rayton is the same as the distance from Tunbridge to... Okay, I'm going to have to draw this out. So, because this is going to be some equilateral nonsense. Not equilateral, isosceles. Come on. So, bearing on 210 means that's 30. the bearing of Uphampton from this guy. So then I'm going to draw north, and I need that full angle there. Well, that is going to be 30 because angles in parallel lines. I can see z angles, so that is 30. And there's 150 degrees left, which means those are both 75. So the bearing of that from there is 105, which is C. We are nearly there, guys. 17. List of 5 numbers has a mean, mean, median, and range. 6 numbers added to the list. The 6th number is greater than x, which means it is going to raise the mean. So it was 1, 2, 3, 4, 5, where that was y, and that minus that was z. A number is added here bigger than the mean. We don't know it's added to the top. It could have been added in. It could have been slotted in here. So we do not know that the range has gotten bigger, because if it was slotted in here, that the top and the bottom would be the same. It would just slightly raise the average. We also do not know that the median has increased. So it could be one of the numbers in the list if there were 2 y's, for instance. And then let's say this was the biggest, and then a number was slotted in here. So the only thing that must be true is 2, that the mean is greater than x. Okay, and final question. For 18. Solid pyramid has a square base, side length 12, vertical height of h. Volume is equal to the total surface area. Nope, don't do that. Don't do that. Okay, so we got to work out. So the volume is a third area of the base times the vertical height. Okay, let's do this. So that's 12, that's 12. We can draw a diagonal, which would be 12 root 2. And then I can draw, so that's 12 root 2 divided by 2 is 6 root 2 on the bottom, and I have h there. Okay. Let's lay it out. So the volume of the pyramid is a third times the area of the base. So it's a third of 144. Well, a third of 12 times 12, which cancels for 4, so it's 48 times the height is the volume. And that's equal to the total surface area. This is not what I wanted to do for the total surface area. So for total surface area, it's obviously 144 plus 4 times the area of the outer triangles. And the outer triangles have a base of 12 and a height of something. And that something is found by having 6 and h, by sort of drawing that out, the side length, that, and then I get the hypotenuse. So that becomes the root of h squared plus 36, which is this guy, root of h squared plus 36. So half base times height on that is 6 times thingy. 6 root h squared plus 36. For one triangle, multiply that by 4 to make that 24, and add the 144 to give the total surface area. I've got 3 minutes-ish. I got, in fact, a little bit more than 3 minutes, so I think I should be fine here. So 48h minus 144 equals 24 root h squared plus 36. Let's divide by 24. That's going to give us 2h minus. I want to say, if I call that 12 times 12, and then I divide by 24. Cancels for 2 minus 6. So 2h minus 6 is root of h squared plus 36. Square it up. 4h squared minus 24h plus 36 equals h squared plus 3. 3h squared minus 24h plus 33 equals 0. Divide by 3 because I can. Plus 11 equals 0. And I'm not seeing a... Oh, man. Okay. Man, something feels off here. Volume of the pyramid is equal to the total surface area of the pyramid. So the volume of the pyramid is a third times the area of the base, which was 12 times 12. So a third times that would give me 48 times height. That is absolutely that. H 6 root of h squared plus 6 squared, which is 36. Good. Is the height of that triangle. Half base is 6 times that height. Good. Times 4. 6 times 4. Good. Plus the 144. Minus the 144. Divide by 24. That is absolutely 2. That is absolutely 6. It's 36. Those cancel. So h into h minus 8 equals 0. And h equals 8, which is E. And I have a minute left in which to go back and just check too, because I wasn't warmed up and I just said I wanted to come back to that just to check, because I signs are an issue for me in inequalities, and I just wanted to check h, x has to be bigger than 10. Can I come up with an example? Well, let's take in which case, let's take as it tends to infinity. Then this will become approximately, in fact, I've only got 30 seconds. That would become approximately, it would tend towards 3 over 2x minus 2/3 x, which is decidedly less than x. Yes, so it does work. Okay, I'm going to lock that in with 10 seconds to spare. Right. Now, just some initial feedback. You could see, this would be a good training run for me, because what I'm clearly going to have to practice is how to hold that, I don't want to do this energy as I'm going through it. Because this is what happens to me. I know when I get tired and a little bit cranky, I get a little bit internally whiny, for want of a better word. I'm like, no, I don't want to. And that's just a personal thing I'm going to have to get over, because if this is the real thing, deal with it. It's just something I'm going to have to deal with. So I can feel the temptation, and I kind of rather I just sort of hold that and go, nope, 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 nope. Best day ever. My brain is absolutely on fire. Nothing's going to stop me. Denial, full denial. Keeping myself to task and not letting my emotions get in the way of my performance. So let's go through now. I'll point out any notable splits on the way, and kind of we'll talk through how that went. So looking at the answer key, 1F. In fact, I'll go through my splits. Yeah. 2H, good. 3E, good. 4C, good. 5E, good. 6D, good. 7B, good. 8F, good. 9A, great. 10D, good. 11E, 12G, 13D, 14G, 15C, 16C, 17C, 18E. Boom. Okay. Now I'll go through, see if I need to give anything a bit more explanation, go through anything notable in the split times. So let me see if there's anything I need to do with this. Standard, this pretty standard. This, I think you should be fine with. This, again, I don't think you have any issue here. Anything in my split times? No, these were all quick splits. All under a minute, actually, except for set question 2. Nope, standard. Length, area, volume, just making sure you remember this from GCSE, because it may be that you haven't seen this in a while. And you'll notice, okay, so in terms of actual technique here for ESAT, good simplification skills where possible, because I was like, I'm not doing 27 times 192. No, no, they are not paying me enough for that. They're not paying me at all. Like, I'm going to do it the laziest possible way. And so I just sort of canceled down to keep the numbers easy until I could see how it would simplify, and then 27 times 3. Knowing as well in terms of minimizing execution errors, because that's the real killer, especially in Math 1 for ESAT. So the questions are typically easy enough that you can conceptually understand what to do, but they're difficult to execute. So you need to employ good skills to make sure you're executing well. And for me, not simplifying too much too quickly is how I know I'm going to stay on track. So I could have done 4s, but I was like, that would have been mental effort, and no. So I just canceled out a 2 first, and then was going to keep going. Spotted that it canceled for 3 immediately, and I know 27 times 3 is 81. Then we start getting into me taking too much time, and this was because of that execution error. That didn't put me off too much, but I'm playing the mental game and saying, all right, if I know it's not factorizing and I'm getting clean, I should be getting clean answers, and it should factorize, then something has definitely gone wrong. And so that was my context clue to look for some sort of execution error. Spotted it quite quickly that should have been 9x squared, and from there it was smooth sailing. But it did cost me time, and this one took me 1 minute 56, which was a little over average, but I knew the previous ones had gone well, so it didn't put me off. This was pretty standard power law stuff. This, I didn't have memorized the area of a rhombus, so I did have to derive it. But what I did know is that the diagonals are perpendicular bisectors. So it would split that in 2 to give me 4 minus x and 4 minus x. And I knew I could get the area of a triangle from that and double that up. So it really was just the fact that the product of the diagonals of a rhombus equal the area of the rhombus, which, cool result. Didn't know it. Did derive it, so it was worth it. It worked out. From there, I just made rigorously sure that I didn't finish the question there. I plugged it back in for PR, and you saw how like mechanical I was not to make an execution error. So 3 times that is 1 plus 2 is 3. 3 times that is 9 plus 2 is 11. Good. Note those down. The difference between those was 8. This on question 10, that took me a little long because I was deriving it. So that was 2 minutes 5, definitely overtime. Then 11, this took me far too long. This was 3 minutes because I immediately reflexively went for the 3, 4, 5 result. These are not the same thing. I went for the 30, 60, 90. It's not a 30, 60, 90. I needed to look at it a bit closer, but it was similar triangles. And scaling similar triangles is such an ESAT skill, so definitely one to get good at if you're not feeling as practiced in that. So that was a worthy 3 minutes spent. But then I know how to do ratio work. This was more standard. Started clawing some time back. That was 111. This again felt fairly standard for 1 minute. 14, I was like just trying to do it in my head. It probably wasn't very clear when I was doing it. I like how I did it with the lengths and therefore what that would make the new coordinates. So I found that R would go down to there, and when you flip that in the x-axis, it goes up to 7.1, and that was sufficient. So I stopped. 15 was fairly standard as long as you follow the question. 123, that was good on time. And then obviously this final one. Oh no, I just lied. Okay, so this was 104. This was fairly fine as long as you remember angles and parallel lines and isosceles triangles. So 17 was the most interesting. It's actually the one that feels most similar to the TMUA stuff I've been doing. Oh, watching from Gaza. Hello, Hafaz. Thank you for the videos. It helps me a lot in my application process at Cambridge. Well, all the best with that. Oh, if you're applying to Cambridge, you should be tuning into my my interview series. So I'm going to be once a week doing a live interview skills seminar. So I think that's it's gonna be on Thursdays. It's gonna be quite late for the time being. I know I'm gonna try and move it earlier, but I've got some scheduling stuff to rearrange. Definitely check those out. And also, all the best. Hope you get in. Gossel's not the safest place in the world right now, so landing you in Cambridge is very much something I want for you. Okay. But if you're applying to Cambridge, you've been through this process. So, and also, by the way, if you've got any particular interview stuff you want to go through, feel free to drop a comment at any point, and I can definitely make sure I go through that. Right. So this question in particular. So what I knew, it was bigger than X. So if I plug in a number bigger than X, it will definitely raise the average. So I knew that 2 was going to be correct. But again, if it's only so if that was the middle number and this number was like y plus 100, and then I slotted in the new number power where technology just hates me. Okay, story time. So I got research placement one summer at Caltech. Every piece of equipment I needed to use broke at some point during my experiments. And when I stood up to let them know at the end of my project that nothing had worked, every projector in the building stopped working at once. To which you say, "Oh, you were just the first presentation. The projectors weren't working." Not so. The 2 people gave presentations. I then stood up. Every projector stopped working on the spot because I am that guy, which is why I do not work in science. So yeah, apologies for the technical glitch. That was quite spectacular. Anyway, back onto it. So if that was y, which is the median, y, let's say that this was already y plus 100. If I slot one in here, which is a little bit bigger than x, then it won't have affected the range. It won't have affected the median, which is now 6 numbers with 2 y's in the middle. So the median is still y, which is very much in the list. It only would have raised the mean. So that's how I got around this. And then I think 18 was difficult, but I did it in quite a systematic way. And once again, the quadratic didn't factorize. So I just got a gut sense, not working out. This is not how to do it. And that's really important for interview as well, is assessing how likely it is that your work is correct. Have these sorts of red flags. That doesn't factorize, red flag. And same thing before. So just kind of keeping your finger on the pulse. Is this sensible? Is this accurate? Is this right? Alrighty then. So moving on to, in fact, we won't do physics because in the real thing, you have to go straight to the math 2. And that felt different in terms of a run, actually. So when I start from the back, I know to more actively skip. Whereas when I did this run, starting from the easy questions, I kind of got lulled into a false sense of security that I should just do every question as it comes. And I find that really interesting. So I'm going to do math 2 from the back this time to really incentivize me to do some tactical skipping. 18, but there's actually only 9 questions, so I only have 13 minutes and 20 seconds on the clock for this. So let me start the clock now. All right, so 89. Complete set of values for which that is bigger than 0. I'm going to come back to that. Tactical skip. This I can do. I like trig. So 87. And I'm going to say, so 3 tan minus 2 sine is 2. 5 tan plus 6 sine, oh, come on, tech, is 8. Let's solve these simultaneously. Triple that up. 9t minus 6s is equal to 6. Add them up. 14t. That 0 is 14. So tan is 1. So alpha is 45, which was irrelevant. So 10 is 1. We need to solve for s. So 5 plus 6s equals 8. So 6s is equal to 3. Sine is equal to a half. Sine of... So beta, I can never be bothered to learn these. 1, 2, root 3. sine, so that's 30. So theta, the third, so there's 75 degrees currently accounted for, so 105 is left, and that is D. Okay. Yeah, I can integrate. Not an issue. 85. So I'm going to integrate that up. So this is going to go on 3 plus 2t 8 over 8 x and 0 an eighth 3 plus 2x to the 8 minus an eighth of 3 to the 8. What's the coefficient of x to the 4 in that? Well, this is not going to give me any coefficient of x to the 4. I just need x to the 4 from this, which is going to be an eighth of 8 choose 4, 3 to the 4, 2x to the 4. That is 8 times 7 times 6 times 5 times 4 factorial all over 4 factorial. 4 factorial. Cancels, cancels. 4 factorial is 4 times 3 times 2 times 1. 4 and 2 cancels with the 8. 3 cancels with that to give me 2. That gives me a 10, so that is 70. An eighth times 70 times 9 to 81 times 16. Cancels for that for 2. So hold on, it's going to be 140 times 81. So it's going to be certainly bigger than 5,000. So it's one of these two. And the first non-zero number should be a 4, which is wrong. Damn it. All right, tactical skip. Come back to 85. I'll sort that out. I forgot to divide by 2. No, pause. Okay, I know what I did. I should have also divided by this 2, so that should have been 1 over 16. So the 6, it should have made that 1, so it was just that, which is 5670, which is E. Okay, that was a good catch, and a wobble what wasn't worth it. So here, let's redeem myself. No, calm. Doesn't matter I made that mistake. All the other questions really matter. I've got to keep my head in the game here. So that integral, I'll call A plus B equals 4. So in fact, hold on. So if A is the integral just by itself, integral of f of x from -2 to 2, that is 2a, taking the 2 out the front, plus b is equal to 4. This is 5a minus, now this is the integral from -2 to 2, and then the integral from 2 to 4. So that is a plus b equals 7, which means that 4a minus b equals 7. Double that up to give me 4a plus 2b equals 8. That minus that is 0. That minus that is 3b. That minus that is 1. B is a third, which is what I was looking for, which is a. All right, we're back on it. Okay, this should be fine. 81. So 3 times 5, so that's 15 times 5 to the x squared minus 5 to the x minus 2 is 0. So that would, so 15, this feels, okay, it's going to be 3y and 5y if y is equal to 5 to the x. It's going to be minus 2 plus 1 is 0. So 5 to the x is minus a third, or 5 to the x is 2/5. You can't, this has no solutions. And we're taking log 5, so it's log 5 of 2/5 is b. Okay. Here, 79. Equilateral triangle. So its vertices lie on a circle. What is the total area? Total of the 3 areas. I'm sure there's a fast way of doing this, and I'm sure I'm not going to find it. Um, mm, 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 mm. Okay, so the area of the equilateral triangle, if that is 8, then it's a 4, 8, 4 root 3, 1, 2 root 3. Area of that would be, and so the area of the full thing is a half base times height, which is 16 root 3 for the equilateral triangle. Let's see if we can find the radius here, which is that, nope, is the height, that guy. So that's 4, and that's R, and that's R, and that's 30. Let's do a resolving triangle. So it would have been a 1, 2 root 3 with a 30 on the top. It is now a something 4R with a 30 on the top. So divide by root 3, multiplied by 4. 8 over root 3 is the radius. The area of the circle is pi times that squared, which is 64 over 3, minus 16 root 3 for the total. So I can take a 16 out. It becomes 16 into, in fact, I can take a 16 over 3 out. That becomes 4 pi minus 3 root 3 e. Okay. Um, 77. So 7c plus sine squared over cos is equal to 5. So 7 cos squared plus 1 minus cos squared equals 5 cos. 7 cos squared minus, nope, 6 cos squared, because that cancels, minus 5 cos plus 1 is 0. So that is 6 cos, that's minus 1 plus 1, so it's minus 6, but good. No, lies. Lies, because that should be plus 1. So instead, what I need to do, possible values of tan. 6 cos, that's sine over cos, sine squared over that. Sine squared is 1 minus cos squared. This is good. 6 squared minus 5c plus 1. Sorry, it's 2 and 3 minus 1 minus 1. So cos is a half or cos is a third. And if in this everything is positive, so let's draw triangles for which this is true. If that's 1 and that's 2, then that's root 3. And tan of that is root 3. And for this one, 1, 3, this would be the root of root 8, which is 2 root 2, and tan is 2 root 2. So I get D. This curve has a local minimum. Let's differentiate. 3x squared, 2px, and q has a local maximum when x equals 1, so 0 when 1, so plus 2p plus q. And a local minimum when x equals 3. So it's also 0 when x is 3, which makes that 27 and 9p and 3q, which I can divide by 3 to give me 0 equals 9 plus 3p plus q. Let's subtract these two equations. That minus that is 6. That minus that is p. That minus that is 0. So p is minus 6. And that's not an answer. Try again. 3x squared, 2px, and q. Actually, it was minus 1. Minus 1. Okay, so that should have been minus 3. That's still plus. That should have been minus q. When 3 27, 9, 3 still works. Still divide that by 3. That minus that is 15. That minus that is P. That minus... add them together. I'm running out of time. Add them together. So 0 equals that minus that plus that is 6. That plus that is 5p. That plus that is 0. So p is minus 6 over 5, which is not an answer. Okay, so because that should have been 2px. Patrick, focus. Get marks. 0 equals minus 1 makes that 3 minus 2p plus q. 3. 0 equals 27 into here, not into there, into here, plus 6p plus q. We can immediately subtract. So 0 equals 24. That minus that is plus 8p. 0. So p is minus 3. There we go. B. Okay, I've got less than a minute left. God damn it. Bad run. All right, I'll keep going just to say if I could have done it. Let me get some guesses in. Bounded by that. Okay, so the first one I'm going to randomly guess B. And for the final one, I will randomly, because I just got to get some, let's see if I can get lucky. It's bigger than 0, so it's going to be bigger than 0 for some intermediate, and then for definitely all of them at the end. F. Okay, done. That was not a good run, but I'll keep going. Just to sort of confirm for myself that I could have got the correct answers if I had the time, and then we'll go through why I didn't have the time and what I could have done better in my run. So here, let me actually do 73 a proper. Okay. And I've got the split time, so I'll be able to analyze. So we have axes, x is minus 6, and that is y equals minus x plus 4 all over 2. So it's doing something like that. Where when x is equal to minus 6, y is equal to 5. And when x is equal to 0, y is equal to 2. So that is 5, that is 2, that is 6. Half base, average of the parallel sides. Well, in fact, I'll just do 3 times 7 is 21, which was C, which I did not guess. Oh, well. Time management was bad there. Not a great use of my multiple pass system. So the complete set of values for which that is bigger than 0. Well, I'm not very well going to factorize. Oh, actually, I could factorize that because I can see it's going to have these factors. So I can take an x plus 1 out, for instance, and be left with x squared minus 3x minus 4, which is x plus 1, 4, x plus 1. Oh, this would have been fine if I used exam technique. Because I could have spotted the minus 1s and the 4s. I could have been... okay. So sketching that, you hit minus 1 first. It's a turning point, and then it goes up at that. So the correct answer is F, which I did guess. All right, so that's me actually making an attempt at every question. Let me actually mark it up now, first of all, and then I'll look at my splits and see what I could have done better in the run. So here, 87. Was D correct? 85E, correct. 83A, 81B, 79E, 77D, 75B, 73 was C, which I got at the second time round. This one was F, which I guessed correctly and then got the next time round. Now, realistically, by the way, it's much more tricky to do these short runs because you don't get that same leveling out. So I didn't have. So you saw in the math one, I had time to like pivot. I had time to make up because there were other questions where I could build up a time bank. Whereas this, if something goes wrong, it has a much more consequential impact on like the percentage of time you have left. So it does affect it more in the short runs. And I think if that had been a fuller run, I might have been able to claw that time back. But let me look at the splits and see what I did wrong. So here, I skipped this one quickly. I took 1 minute 20 on this. That was good. I took 152 on this, which was too long because I forgot to divide by 2 when I integrated. This one was fine, I think. This one I think actually only took me 30 seconds, which is bananas. This one was fine. In fact, things were largely fine. When did they stop becoming fine? Hold on. So this was question. Please pause while I take my split times. So that was 11. This was, and this is something you should really do with yourself as well to really get into the data and think, where could I have made my gains? So here, 120 was fine. This was 152, not fine. This was 30 seconds, fine. This was 30 seconds, fine. Sorry, this was 1 minute, fine. This was also a minute. So this was all going well until, yeah, then the wheels fell off. So this took me far too long because I didn't. Yeah, okay, so so clearly I need to get a little bit faster factorizing these harder quadratics. And that was really the issue. Then, obviously, we all saw what happened here, and that wasted so much time that did not need to be wasted. Okay. Cool. So just a little bit of accuracy, a little bit of and ironically, these were the ones at the start, which should have been easy. So it's funny how the dice roll on that one. Okay. By the way, while I'm here, I will also add that I've set up a public facing email. So if you did want to get a parent to put in requests for actual tutoring, since we're nice and small, that's quite sustainable. I'm not going to get like flooded with stuff. But if you did want some tutoring going through your process, that is something I'm now able to offer. If you just get a parent to drop me an email at that public facing website, we would do a consultation call with the parents just to make sure that they have full consent, they have full awareness, they know what I'm about. It's making sure all the communication is done with everyone looped in, so the parents are all fully in the loop. We would sort things out sort of business-wise and get it all sorted from there. So if that's something you're curious about, it is something I now offer, by the way. Right, so now let's dig into the physics, which is more up top. How do I want to play this one? Do I want to play this one? Okay, I'm going to do this more. I'm going to do it from the front because I want to get better at skipping even when I think I know how to do it. So like I want to get better. So I've proven to myself I can use the multiple pass technique from the back. I haven't proven that I can do it from the front. So I want to spend a little bit of time just going through that. Not looking at the question too much. All right, let's get this run done. Let's close it out. Again, 26 minutes, 40 seconds on the clock. Let's go. Okay, so 19. A distance between successive wave peaks is 8.4. That's the wavelength. Total distance traveled during one oscillation. So it goes up, down, down, up. So that divided by 4, I think, is 1.3. It's 1.4. So the amplitude is 1.4. Wavelength, 8.4. That's B. Yeah, I can get into this. So this is work done. Naming the skill, very important to lock in. So that is the mass. So the mg h for one rock. Total work done on 10 bags is that. And the average power required is that over 2.5 times 60. So let's work out what those two quantities are. So the work done, 1.5, 37.5. So 100,000. So it should be in the thousands. So 37. So it's E or it's F. And that over that gives me 10. That 6. That 0.25. So a quarter of 100 is 25. So I think the answer is E. So I have to always think, can I do this? Should I do this now? I'll come back to this just to get in the habit. 21. I like electromagnetic waves. So 22. Travel in a vacuum. The wavelength ratio is that. Well, their speeds are the same. It's the speed of light. So it's something A through D. Frequency, wavelength. This has the bigger wavelength, so it has a smaller frequency. So it's going to be A or B. P has the larger wavelength, so it cannot be the microwave. So I think it has to be B. Q, oh, I love Q equals MC delta T. Let's go. So Q equals MC delta T. Knock 2 zeros off. 9 from that gives me 60. Over 0.8. 600 over 8. 300 over 4. 75. So delta T is 75. Up from that is 54, which is C. Okay. A classic physics ESAT 1, 2, 3 question. So 24. Range of loads. Spring obeys Hooke's law. System is in equilibrium. Tension is not directly proportional to the length. It's the extension. These are not a Newton's third law pair because weight of the load is Earth acting on load. So the opposite of that would be load acting on Earth, not the tension in the spring. When the extension of the spring is doubled, the energy stored is increased by a factor of 4. That is true because it's proportional to x squared. So it's 3 only, which is D. This I'm going to pass because it just feels like it's going to take time. So I have to come back for 25. I like transformers. Okay, so 26. Second coil of I. So NVIP, NVIP. 100% it's connected to resistor by cables thingy. The secondary coil, the current of the primary coil is 4. There are 240 turns there, and 4, so that's a factor of 20. So the current should be 20 times smaller, which makes that 4 over 20, which is a fifth, which is 0.2. And the power, and restart. So what we know is, we know the current P equals I squared R is 1/5 turns into 1 over 25 times the resistance of 1500. Let's multiply by 4 to make that 100 and multiply that by 4 to make it 6,000. Power is 60 watts, which is A. I really do like heat. So here, 27. Heat is supplied to initially solid substance. This rate, that is it melting. Later fusion, so we know it's melting from there. Q equals ml. Mass is in grams, this is fine. What's the time it takes? So 15 goes to 60, so it takes 45 seconds. So the power is 60 times 45 equals 100 times the mass. Zero 0.6 times 45 is not fun. Let me divide this by 100 to get the mass. 5 makes that 9 and 20 for 3, so the mass is 27 grams, which is E. Good simplification there. Now this, I happen to understand this, but this is the formula that loads of people hate, so I'll come back and explain later. But one tank contains 90, the other tanks, which of the following conditions is thermal energy conducted at the lowest rate? So for the lowest rate, we want the biggest temperature gradient, so we want big theta and big L. So these are similar temperatures, very separate. So big theta would be 40. Big L would be 80. So it's either F or H. And then D, we would not want it to be able to move so much, so we want small d, so that would be F. And I'll explain that more later. F equals BIL is a great formula, guys. So a straight horizontal wire of length 5, fixed position between the poles of a magnet, perpendicular to that. There's a current with it reversed. So what this means, so in the first instance, the force is acting down. In the second instance, the force is acting up. So 2 times that force is equal to 4 grams worth of weight. So 4 grams times 10, that cancels down for 2. So 2,000, so 0.02 newtons. So F equals B times I times L multiplied by 100. B equals 0. Nope, that's not an answer. F does equal BIL though. B times I times L. Of course. 0. So that was 10. 2 divided by 10 is 0.2, which is C. So no issue there at all. Radioactive isotope. X becomes the stable isotope Y after a succession of decays involving Only emission of alpha and beta. During the decay of one nucleus, a total of 7 particles are emitted. More of these particles are alpha than beta. I'm just gonna my brain's not liking, it's not locking in right now. So I'll second pass that. I'm sure I'll be fine. Okay, this kinetic energy is fine. Mass 4 kilograms traveling a straight line increases from that to that in that as a resultant force. Okay, so this is going to be change in speed. So half m, so 2u squared is 32, u is equal to 4. And that goes up to v equals 10. So change in speed is 6 over time of 3. So the acceleration is 2. F equals ma is 8, which is c. Okay, that was fun. That put a smile on my face. Here, all 5 resistors have the same resistance. 1, 2, 3, 4, 5. Reading on this volt, so that is 1, which means that is 1. So that is 2. The voltage across here is 2. Let's work out the resistors. So 1 over R plus 1 over 2R, 2, 2, 3. So that whole thing is a 2/3 R, which has a voltage of 2 across it. And in proportion then, so 2 ohms would therefore have a resistance of 6 volts. So 2 plus 6 is 8 volts is E. I will explain that in more detail later. Okay. 33. So we know that the total initial momentum so it's 20,000 to the right, 20,000 to the left. So the total initial is 0. Total initial to connect half m times speed squared. Let's get that. Half well, I'll say 1 to make it kilojoules times 20 squared. So it's 200 kilojoules for that one. And half m and 100 kilojoules for that one. So it's 300 kilojoules for 0. Okay, so then the average force on each hovercraft, they stick together so that it will stop. So change in momentum is 20,000. So 20 kilomomentums. So 200 kilonewtons. So therefore F. In 85 seconds. Oh, okay. So distance is area under the curve on a velocity time graph. So for 34, this is 60 times 16, which is 960. And there, this triangle is half base, so it's 5 times 16 is 80. This is half base times height is 8 times 15 is 120, 200. So 960 all over 160. Knock that off. Oh, how do you simplify? I know you divisible by 4, which would give you 24 over 28. No, 29, which is D. Okay. 35. So I feel like I've got good momentum now. Cylindrical channel to accommodate a hot water pipe. Cylindrical hole in the middle. Diameter is 14. Gotta be careful now. Density of the material. Cylindrical hole. What is the mass of the block? So it's that minus that. So let's think about the volume. So the volume of the thing is 22 times 22 times 100 minus the area of that thing, and the diameter is 14, so the radius is 7 squared, so 49 pi times 100 is the volume. Take pi to be 22 over 7 if you insist. Cancels for 7. So 7 times 22 times 100. Well, that's important. And the mass of the block is density times volume. So all of this times 0.1. So in other words, these will all cancel down, and this becomes the mass in grams. So the mass in grams is 22 times 22 times 10 minus 22 times 7 times 10. So in other words, it's 220 into 22 minus 7. It's 220 times 15 is 110 times 30 is 3300 is 3.3 kilograms is B. And I'm looking at the clock and I've got good time left for the run. Initial contains equal numbers of x and y. So x and y was in the ratio of 1 to 1. In 6 years, x has undergone 2 half-lives, so it's gone to a quarter. And the remaining 3 quarters has gone into here. So it's now a 1 to 7 ratio, which is B. Okay, so I have to go back for 21, 25, and 30. Okay, so here. Diode is connected in series with a resistor and a 6-volt battery. Let me draw this out. So 6 volts. Diode, resistor. The current in the circuit is 8 milliamps, which means that the voltage across the diode is 1.2 volts. Which means this must be 4.8 volts. And V equals I times R multiplied by 1,000. So 600 equals R, which is F. Okay. I need to go for 25. Watertight cylinder. Piston contains that much of trapped air. This is clearly going to be a Boyle's law thing. Constant density of that. Watertight cylinder. And a piston. So the density of that, the volume of air decreases. Okay, so P1V1 equals P2V2. So 110.5 times 210 minus 3 equals P2 times 410 minus 4. Well, that's 0.4 times 10 to the 3 minus 3. Cancels. So the original pressure, 2 over 0.4 is 20 over 4 is 5. So P2 is 5 times 10 to the 5. So the extra pressure due to the water is 4 times 10 to the 5, which is rho GH, which is 1,000 times 10 times H, which is 10 to the 4 times H. So H is 40, which is A. Okay. And I'm doing well on time for my final question of 30. So radioactive isotope X becomes the stable isotope Y. One nucleus, a total of 7 particles are emitted. More of them are alpha than beta. Okay, so X was a Z. What could the atomic number and mass number be? So it's either 7, so it's either 4 alpha or 5 alpha or 6 alpha or 7 alpha. If it was 7 alpha, there would be minus 28. So none of those are the answer. 4 alpha, that would be that minus 4. So it would be Z minus 1. None of those are Z minus 1. So this would have Z minus. Oh, lies. Lies, lies, lies. Lies. Because okay, so 4 alpha, that would drop it by 4, 2 each time. So that would drop it 8, and then add 3 back, so that would be Z minus 5. So it could be B. If that was the case, then A would have dropped 16 and stayed at 16. So it's not B, so it's not that. I should really have gone down the multiple choice instead. Oh well. This would have dropped this down by 10. So Z minus 8. It's C. Good. And I've got a few minutes left. I'm just going to stop the clock there and see how I did. Because again, this is more about just sort of doing a practice run when my brain isn't working as much. You can see my brain kind of warmed up through this, which is good to know. Let me mark it up and see how I did. And then, right, then I'll look at the splits and see if I could have made any corrections. I had an extra 3 minutes on the clock. So that's kind of what I was saying about doing the physics run versus doing that math 2 run. The math 2 run, like I didn't have as much time to build the time bank back up again. But let's have a little look. So 19 B 20 E 21 skip 22 A. No. Okay. What did I do there? Okay, I just didn't. I tried to do it in my head. Oh, I'm an idiot. No. Oh no, 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 no. It's got the long P is the longer wavelength, so of course it's that. Oh, that was silly. Oh, that was just a little execution error. If I'd taken a few extra seconds, I'd have been fine on that. Not okay. Okay, so it just wasn't locked in fully. 23C, 24D, 25 skip, 26A, 27E, 28F, 29C, 30 skip, 31C, 32E, 33F, 34D, 35B, 36B. Then going back, 21F, 25A, 30C. I would have got full marks on that if I had just thought a little better. Yeah. So it's, oh, and that's so stupid as well, because it's clearly got the much smaller wavelength. So Q has the massive wavelength, which is, that's disappointing. I like that topic as well. All right, but it happens. It happens. You just sort of got to roll with it. And then you, like, the more execution errors you make like that, the more you kind of think, not next time. You know which ones you've made, you know where your brain is likely to falter, and you learn to sort of cope for that, adjust even. So let me go through split times, see if there was anything worth mentioning, because that run felt like it went a lot better, and let's find out why. So in my first pass, 29 seconds, 1 minute 18, skipped in 10, 44 seconds, 51 seconds, 48 seconds, skip there. All of mine, there was only one question, which is above time. Yeah, this was a good run. So the splits look good. So I only started really going above 130 when I was either heading towards the end of the first pass or in the second pass, which means I was skipping well. Let me go through now and do any further explanation on anything that I rushed. I think this was okay. The wavelength is pretty self-explanatory, but where it travels in one complete oscillation, it goes up, then down, then back up again. So it's doing 4 amplitudes worth of travel to make that 5.6, which means that 1 amplitude's worth is 1.4. That's where that came from. This was pretty okay. This was pretty okay when I did it. This would have been fine if I'd thought it through. But I'm over it. I'm fine. Guys, I'm fine. Absolutely fine. This, pretty self-explanatory. Okay. Get really good at Newton's third law pairs. So a Newton's third law pair is one that works when you flip around the order. So for instance, the reason why I'm not like accelerating through the floor right now is there's the force of me on the chair and the force of the chair on me. Me on chair, chair on me, Newton's third law pair. Earth on me on earth, Newton's third law pair. But my weight and my reaction force are not a Newton's third law pair, because that would be force of me on chair and, wait, it would be force of chair on me and earth on me, not the same thing reversed, so not a Newton's third law pair. That's the quick and easy way to quickly establish whether you've got third law pair in action. That one is easy to miss, but it's really, in fact, I can, we can get, no, I'll keep this in case of my working. That it's to do with the extension, not the length. Okay, this, really easy mistake on this one. If I go back and find that, a really easy mistake here is to say that because the second pressure is 5 times 10 to the 5, that therefore that is the pressure due to the water. Not how that works. You have to remember there's also the air pressure acting on top of that water, which means that you need the pressure differential. So the extra pressure is due to the water, and the extra pressure is 4 times 10 to the 5. And that's the one you use. The other mistake would have been not multiplying by G. Nope. So, no, still no. Tech, stop it. No. Let me go back to 100. Cool. So here, let's go back up and find 26. See if there's any. So I just like drawing out the primary and secondary. Keeping all my information in a nice clean table makes me not make execution errors. Highly recommend it. And again, my simplification, I couldn't be bothered to divide by 25. multiply top and bottom by 4, turns it into 100, so much easier to cancel down. So here, this was pretty self-explanatory, where again, good cancellation is the key to doing that quickly. Okay, 28. 28. People hate this. Factors affecting the rate of thermal energy transfer. There is an equation for this. The rate of energy transfer is K, where that is the thermal conductivity, times A, which is the cross-sectional area, times the temperature gradient. Now, there's this equation which you can learn. It's not on your syllabus, and I don't even think it's in the spec, but it is the equation that governs this behavior. The other way you can think about it is clearly it's going to be dependent on the temperature gradient. But also, actually, because this is a metal, the thing doing the conducting are the conduction electrons, exactly the same way as electricity. So anything that resists the flow of conduction electrons also resists the conduction of heat energy. So therefore, the equation actually links very similarly to the resistance equation. Resistance equals rho L over A. And we can see that the rate of thermal conduction flow, the rate of the flow of thermal electrons is going to be like current. Only instead of potential difference, it's going to be the temperature gradient causing this. But so basically the current is V over R, which is something times, and instead of it being V, it's going to be delta T. So this delta T over L becomes the temperature gradient. Ooh, apologies. The A is there, and this 1 over rho gives you this sort of like thermal conductivity idea. So that's kind of where this comes from. So what this means is anything that is decreasing, if we want a low rate of thermal energy transfer, means we want a low current of electrons, which means we want a high resistance. And you know from this equation that you get a high resistance by increasing L and decreasing D. So just from that alone, max L, min D means you're picking between E and F. And between the two of those, it's clear you get the minimized flow of thermal energy when the temperature difference is the smallest, and that would give you F. So that's getting you to think about the relationship between thermal energy transfer and resistance, electrical resistance. That's a good place to start because that's what you already have a good understanding of from your syllabus. Alternatively, you can learn this thermal conductivity equation and put that into practice. So definitely worth doing that in a bit more detail. Glad we had that opportunity. Here, another one, F equals BIL is the equation that governs this. So here, let me bring my little pen tool back in. So here, if I draw it out, in fact, if I, whoop. So we have a length of wire in a magnetic field. But so if I call that L, then the force on the wire is B times I times L, where that is the magnetic field strength. That is the current, and that is the length of wire in the coil. Sorry, not in the coil, but in the magnetic field. And that is the equation I used to work this out. First, I had to actually work out what the force was. And that was understanding that the change in the mass reading was due to the change in the force on a scale. The scale converts into a weight and converts that into a mass. It assumes that all the force is due to weight. So the change in force is equal to the change in weight. And that force is being applied down versus this force being applied up, lifting it off this string. So the wire itself has like the mass of 200, and then we have the 2 grams pushing down, the weight of 2 grams pushing down, and the weight of 2 grams pulling up to cause this change in the mass measurement. So that change in the mass measurement is due to 2F, F up and F down. So the net swing is 2F, and that net swing is 4 grams worth of weight, which is 4 times 10 to the minus 3 times 10. I cancel the 2's to make that 2, and that canceled to make 10 to the minus 2. So it was a single force was 0.02 newtons, which I plugged into here into F equals BIL. The 0.0's canceled, multiplied both sides by 100. So 2 is equal to 10B, which is where I got that B is equal to 0.2. Okay, 30. I could have done that maybe better by going through the multiple choice here, because, yeah, I could have done it from the mass numbers. So what I could have done here is said, if these were true, how many alphas? Because the mass was going to easily tell me how many alphas would have been emitted. So this would have been 3 alpha, 2 alpha, 5 alpha, 6 alpha, 4 alphas. So we know that more of these are alpha than beta, so it can't be A or B immediately. So it's immediately one of these. So this would have required 10 loss in atomic number. So how many betas now? 2 to gain it up to 8. This would have been minus 12, so I need 2 to get me up to minus 10. This would have been minus 8. And betas do not make the number go down any further. They make it go up. So this can't happen by beta minus emission. And this is the one that gives me 7 particles released. So you could also have used that technique. And it's one thing I need to sort of do better in my runs, I think, is leverage the multiple choice, because I could have done that in the Math B as well. This was much more standard. This I can explain in a bit more detail than what I did. So what I was doing in my head was, so first of all, I'll show you exactly in sort of more granular detail. So if that was 1 volt and these were the same resistance, then that would also be 1 volt because they have the same current and the same resistance, so therefore the same voltage. Voltage is the same in parallel branches, which means if that is 2 volts for the whole branch, that is also 2 volts for the whole branch, which means the entire voltage between here and here is 2 volts. That is where I then worked out the equivalent resistance of this array of resistors and worked out that it was 2/3 R. And I know that 2/3 R in the middle here carries 2 volts across it. And then I did something sneaky. What I then did is said, therefore, 2 ohms resistance, or rather 2 R's worth of resistance, must carry 6 volts. And I spotted that this and this in series would have been 2R. So it would have been the 2R in series with the 2/3 R. So these two together would have carried 6 volts. This bit in the middle I know carries 2 volts. I shouldn't really say carry, but whatever. So overall, it's 8 volts. And I think that was quite a clever workaround there at the end, but that's where I kind of went. I saw that that plus that would have been 2R, which would have been 6 volts, which is how I quickly got to my 8. 33, I think I just did that, and that was fine. This, I think I just did that, and that was fine, as long as you're comfortable working out areas from the graph. And canceling. This, I think, was fine. Just good systematic working. And this, this happens a lot, I find. It's almost once a paper, I find, that they do one of these questions with radioactive decay. My advice is to do it using ratios. So here, I consider the initial ratio as being 1 to 1, and then just consider what happens as the decay progresses. So here, we have a half-life of 3 years. So after 6 years, that is 2 half-lives. So it is a quarter of the original. And the 3/4 that decayed all turn into y. So 1 plus 3/4 is 7/4, which then gives me a 1 to 7 ratio. Just a really good way of handling these sorts of ratio problems. So that is it for that paper. Hopefully you found that useful. Again, this is more like you can see me making a couple mistakes. Just in terms of exam technique, that math 2 wasn't phenomenal. I think in a longer run, I would have been able to sort of make that time up, but like not my best work. I did manage to guess one of them correctly. That's always good exam technique. So I only lost 1 mark in math 2 when I should have lost 2. So maximizing your marks, guessing, always worth it. And I would have got those if I'd been faster. What annoyed me in terms of actual execution errors was that one mistake I made in the physics. That was just me rushing a little bit. That happened earlier in the run. That's something to be aware of, right? Because it's like when you're starting off a run, that's when you're trying to get ahead of it. In your first pass, you're like rushing. You're like, I got to get through. I know this is going to be time pressured. So that's when you're kind of more likely to make those quick execution errors when you're rushing. So that's something to think about when you're practicing is what is my optimal pace to maximize my speed while not introducing those errors. I think one thing I should think about as well, more based on that run is, like I said, the leveraging the multiple choice options against each other, which could have helped a couple of times. So what I could do is sort of my post-game analysis. I could go back through a paper and recognize when I can use multiple choice. What kinds of question lend themselves well to being led by that? So, for instance, the math 2 question with the cubic. All of the answers had a -1 and a 4 in it. I should have clocked that was going to tell me something about the factorization. And for that radioactivity question, like there were loads of options to work out. And if there were loads of options to work out anyway, I should have just gone to the options of the multiple choice. So things like that I can kind of think about. And that's the sort of things you can do in your run. I think you saw me as well kind of deal with I knew I was tired, but I was like aware that I was tired and not really into it. And that was kind of affecting my run. So I think by the end, you saw me kind of come out of that and really kind of come into the paper. But even now, you can see my brain's not the sharpest. I'm not articulating myself as clearly as I usually do, but I'm trying not to be aware of that. I'm trying to like say, all right, given my full capacity of what I've got in this moment, how do I maximize that? How do I get the most out of that? And not let that sort of limitation sort of let that be unconscious, like bringing everything that my brain has to offer to the actual like problem. Words, sentences. You also got introduced to my superpower, which is quite fun. Technology break. That was good. And now I work from home entirely via technology because I make good life choices. Ding. All right. I don't think I'm adding anything useful anymore. I'm just rambling, which is fine. I'll just wrap up by saying I'll keep the papers up. Oh, someone asked when I stream. I'll get this updated. I might get it like a community tab going. I might populate the streams ahead of time. I'm going to continue to do 2 streams a week. I'm going to do a live solve, probably more during the daytime when you guys are in school, because I think that's more useful sort of to view after the fact anyway. And I'm also less responsive in chat because my eyes are like locked on the paper. I will also be doing my weekly Cambridge or Oxbridge interview series for natural sciences and for engineering. I should throw some chemistry in the mix, but I suppose I haven't done any of that yet. So it'll be fine. Um, and when I've got some time on Thursdays, things are going to get rearranged. So hopefully I will begin to be able to do those at more reasonable times. For now, though, with my current workload, it's going to have to be late at night when I don't think people will be there live, but hopefully it will still be useful after the fact. And you can still keep on commenting if you have any questions that you want me to answer. Thank you, Hafez, for joining today. Hope you do very well in your process. I might sort of leave a comment, sort of, asking if you have any particular sort of advice you're looking for. Um, yeah, always happy to have comments. I think especially at this early stage as well, like, let's be real, this isn't a massive project. This is sort of just me, sort of an extension of my normal sort of tutoring thing. So if I happen to sort of help any individuals on the way as well, that's just a massive bonus. And the fact that there are so few people at the moment means you are a massive proportion of my current audience, which means you get big sway. Your comments will be responded to. If you have particular questions, they'll be mentioned in videos. So just feel free. And yeah, I think hopefully I'll settle into a more regular schedule, which means more people can drop in live and actually affect the work that I do. So I'm going to stop rambling. I'm going to let you get on with your day. I'm going to get on with my day. And yeah, I will see you guys for my next stream, which will be on Thursday for the interview. And in the meantime, keep doing what you're doing. Work hard. Have fun. See you guys next time.